Power to the truth. This is Margo. This is Friday, January 11th, 2019. I hope everyone has made it through the week safely. And I was going to do an update on the Antarctic today, but instead I decided to continue with New Zealand and what's going on down there since we started on that yesterday. And Robin Weston just wrote another blog post about the temperature of the ocean water around New Zealand and between Australia and New Zealand and the Tasmanian island here. It's called the Tasman Sea. So what I have is Earth Null School pulled up here, and I have sea surface temperatures pulled up. And so this is New Zealand. The North Island and the South Island is what we're going to be referring to, and this area between Australia and New Zealand is this whole Tasman area that we're going to be discussing today, and also the ocean around on all the sides of New Zealand, about how the temperatures have increased exponentially, and they're worried because the marine life is suffering and the penguins are suffering and everything. And this goes right in line with my report yesterday about the methane hydrates that are off the east coast of the northern island up here, going right and the fault line that comes right down to the east side and then crosses over on the southern island and then runs down along the southern island. How the experts are expecting that to go anytime. So New Zealand is in trouble, and they're in the middle of their summer right now. And so let's just go right over to Robin's blog, and then we'll continue with the show with other stuff. So this is from robinwestenra.blogspot.com from Friday, January 11th, 2019. He actually published this yesterday, but because New Zealand is like 19 hours ahead of me, so he's a day ahead. So I'm reading it the day after he published it, but it's January 11th my time. Anyway, Seymour Rocks. The return of the Tasman marine heat wave in 2019. Once again, Radio New Zealand totally fails to mention the most devastating news for New Zealand. When they do, it is usually disinformation. And here's the headline: New Zealand seas in 2018, hottest since records began, dire warning for marine life. And so here he has a picture from Climate Reanalyzer, and this is the area. This is the 2-meter temperature anomaly, and this is the area we can see. This is the sea surface temperature anomaly. We can see it's all red, and I've been showing that every time I've shown down there that the waters are just way too hot down there. This is from the New Zealand Herald, January 11th, 2019. It is official, the seas around New Zealand in 2018 were the hottest on record. While it might sound nice for your summer dip, scientists are warning the warming waters fueled by climate change could have catastrophic impacts on our marine life. A record-breaking marine heat wave last summer was the key driver of 2018's hot temperatures, with parts of the Tasman Sea as much as 6 C higher than average at times. Those scorching seas saw anomalies such as snapper in Fordland and Queensland groper around Northland, It also saw high mortality rates for both the salmon and mussel farming industries. And here's their chart, sea surface temperatures. 15.6 degrees C was the annual mean temperature for sea surface last year, and it was the warmest on record. And it was 0.87 degrees Celsius above average, the biggest difference in at least 37 years compared to the 1982 to 2010 long-term average. 4 of the top 6 warmest temperature years have occurred since 2013. This is beginning to sound like Arctic sea ice, isn't it? 2016 was the previous hottest with plus 0.74 degrees Celsius above long-term average. And so 2016, their high was, or their mean was 15.4 degrees Celsius. It comes after NIWA announced this week 2018 was the country's second hottest year on record. Scientists say this year the sea was on track for another hot one, with the Tasman Sea and areas just off the east coast currently about 3 C above average, and some a whopping 6 C warmer than normal. Just north of Napier, the sea was currently 24 C, that's 6 C above the average of 18 C for this time of year, and putting it on par with Sydney and New Caledonia, which were both experiencing slightly cooler seas than usual. So I'll show you where that is on our Earth Null School. Napier is right along here, and so they're talking about this area in here, right in this little cove. And right now, and I've got it on sea surface temperature, according to Earth Null School, right now it's showing 21.2 degrees C. And you can also go to sea surface temperature anomaly, and we can see that that's 2.8 degrees C higher than normal. And it's hotter in the yellow-green. Here's the scale. Red is hot, is above normal, and once you get up into the yellows and into the whites, it's much hotter than normal. So even if you move down a little bit, like right where I clicked here, it's 3.1 degrees Celsius hotter than normal. So that's right in line with what this article is saying. According to data provided by NIWA, the average sea surface temperature for 2018 was 15.6 degrees Celsius. That's 0.87 Celsius above the 1982 to 2010 long-term average. And they've got a different chart, or a different model, but they're showing the same thing as what I showed you over on Earth Null School. An in-depth look at current sea surface temperatures around New Zealand. Warmest was 24 C north of Napier, 23 C near Opotiki, and Opotiki is right up here. And that's showing right now, it's showing 21.4 degrees Celsius. So, you know, different models have different things. 23 degrees near Temps, or Temps, 22 to 23 degrees near Auckland, and 22 degrees near Motueka. Okay, so Auckland is up in this cove. It's up here. So we're seeing 21.7 right now. And then what was the other one? And Temps and Auckland are near each other. Motueka is down here at the north end of the southern island. Motueka is right along here, and that's showing 19.7 degrees Celsius right now. 19.4, 19, and the anomaly is 1.4 degrees warmer. So the highest was right here, and in this zone right here near Napier. The highest was off this east side. And then if you look, let's shut that down. This is the Tasman Sea, and we can see it's really high, all right in the middle. So like here it's 3.8 degrees Celsius, and then down here off the east coast of the southern island is 3.3, 3.2, and so forth. Here's 3.7, here's 3.4, and so on. And just to show you here on Climate Reanalyzer, this is what we're talking about, is this red over here and over here. And then the browns are higher too. So the whole area is higher than normal. And then when you get into the reds, it's like 4 degrees Celsius more higher than normal, and up to 5, and then the white is into 6 degrees Celsius higher than normal. These figures have been backed up by the United Kingdom's Met Office, whose figures show 2018 was 1.8 Celsius warmer since their records began in 1854. NIWA said 2016 was the second warmest year on 15.4 degrees Celsius, and 1999 in third at 15.3 degrees Celsius. Since 2013, 4 of the 6 warmest sea surface temperatures on record have occurred. New Zealand's seafood sector, worth $4.18 billion annually to New Zealand's economy, faced some stark threats from these rising ocean temperatures and marine heat waves. And here's a chart, the sea surface temperature anomaly. This is a different source. This is from NIWA. And it says temperatures around New Zealand from January 1st to 7 show parts of the Tasman Sea and off the east coast are 2 to 3 Celsius above average. So, well, Climate Reanalyzer shows it higher than that. So this is probably conservative here. University of Auckland marine scientist Dr. Andrew Jeffs said the changes in temperature could have catastrophic impacts on our marine ecosystem. Last summer's marine heat wave saw a high mortality rate for salmon in the Marlborough Sounds, causing millions of dollars in losses. In the Hauraki Gulf, temperatures as high as 25 C caused issues for the green lip mussel farming industry. They're simply falling off the lines, Jeff said. Sea temperatures do naturally fluctuate, but very gradually and only a small amount. Most species only have a narrow range they can survive in. With temperature changes, species generally moved within their range, whether further south or into deeper water. But when they can't move, eventually they start to lose species. When under stress, marine organisms are also more susceptible to disease. It basically puts the whole ecosystem under stress. Warmer seas could also attract new predators and competition for local species. In Japan, a herbivorous fish wiped out an area of seaweed that had been a nursery for baby lobster. Another factor was the changing of currents. New Zealand is being affected by changes in the flow of the East Australian current, which typically brought more tropical species here and even baby packhorse lobster. We're starting to see disturbance to the natural marine environment, and there's more to come, Jeff said. We've triggered the system, and we're not slowing down, still putting more CO2 in the atmosphere. The ecosystem changes could be catastrophic. It was not all bad news, however, with some species thriving in the warmer waters. We know snapper breed really well in the Hauraki Gulf in warm summers, so after last year's marine heat wave, we will probably have a bumper crop in about 4 to 5 years. The Moana project, led by MetOcean Solutions Chief Scientist Professor Moninia Rugen, was awarded an $11.5 million government grant last year to research New Zealand's marine environment in a time of rapid ocean warming. NIWA meteorologist Ben Knoll said last year's record sea temperature was down to 3 factors. The first was persistent high-pressure systems, meaning plenty of sunlight to warm the top of the water, and light winds to prevent mixing with the cooler, deeper water. The second were prevailing northeast winds driven by La Niña, bringing warm air down from the tropics and a corresponding lack of southerlies. Sitting on top of it all was climate change, which Knoll said was providing a long tail wind to water temperatures. And so here's a chart or graph. This is from the UK Met Office that shows 2018 was the warmest year in our seas on record and 1.8 C warmer since their records began in 1854. So it looks like it's warmer than that. So here are the years starting 1854 down here, and it's every 9 years or so they put up the data, or yeah, about and so 2018 was up here, and it shows at 15.75 C, and when they started measuring in 1854 it was about 13.75 C. So that's 5 degrees. No, that's 13. That's 2 degrees. So there's that. Tasman Sea annual average sea surface temperature. And here's a graph, and we can see it going up and down, up and down. And here's 1985 here, 1990, 95. So this is every 5 years. Here's 2015. And here's 2018. So up here at, or wait, they show that 2016 was the highest at 18.9 degrees Celsius. That's the annual average. So 2018, the Tasman Sea experienced its third warmest year on record with an average temperature of 18.7 Celsius. Last year's marine heat wave was likely still causing the above average sea temperatures at the moment, but scientists were holding off calling it another heat wave, Noel said. Likewise, while the marine heat wave contributed to a record-breaking hot January on land, it was not clear yet if the same would occur this year. But as an island nation, what happens in the sea tends to happen on land, Noel said. Climate scientist Jim Salinger said warmer seas also provided more fuel for storms and meant tropical cyclones would maintain their form longer as they approached New Zealand. The transition from tropical cyclone to ex-tropical cyclone occurs further south than normal, meaning they maintain their intensity for longer. Last year, 3 ex-tropical cyclones came near land, 2 made landfall. In an average year, one might come close to New Zealand. Even a small increase in ocean temperature can lead to dramatic effects on land, Salinger said. Every 1°C increase in temperature means storms hold 7% more moisture. Last year's ex-tropical cyclone Gita brought huge deluges to Motueka, Taikaka, and south of Kaikoura. Radio NZ have reported on this. Penguins suffer under rising temperatures in New Zealand. This is from January 9th. Soaring summer temperatures in Canterbury are causing concern for penguin rescuers. There's a picture of the penguin. The Christchurch Penguin Rehabilitation Center says that between November 2017 and May last year it looked after 40 penguins, but already so far this season, 11 have been picked up either injured or starving. Christchurch Penguin Rehabilitation Center spokesperson Christina Schutt said the hot weather did them no favors. High temperatures made it harder for penguins to find food because the fish they usually caught swam in deeper waters when it was hot, Ms. Schutt said. Yellow-eyed, little blue and white flippered penguins were often found in distress, she said. So, it's affecting all the life down there. So, I just wanted to bring that to your attention. And I don't know why that area is targeted, or I shouldn't say targeted, but it seems like it's set apart like that. I don't know if it's the way the currents are flowing or not flowing between Australia and New Zealand over here, or the pollution in the water, or what. I mean, in addition to climate change, or, I don't know. So maybe we'll see some more articles having to do with this anomaly down here, because when you look at the sea surface temperature anomaly, we do have it around the globe. We are having it, like we are having it up here in the Arctic, that's keeping the sea ice from reforming on this eastern side, and it's here at the tip of Greenland, and it's off the coast of the United States, and we are seeing it in certain areas in the waters around the globe, and here we see it off the east coast of Africa, like between Africa and Madagascar. So I wonder if it has to do with it being an island and being to the east of a large continent or body of land. I don't know. I mean, it's just something to think about. I don't know. If anyone has the answer to that, they can, they're welcome to leave it in the comments. Now, look, coming off the east coast of South America, here's Brazil and Argentina down here. We can see it's red and brown, and then coming across the Atlantic. So, and then here we have our picture that we started with, and then it goes darker brown as it's coming across the Pacific. So, it could be that the ocean currents are just really messed up, and that's, with the ocean heating up and with climate change, the oceans are heating up more, and then the currents are changing. So it could be that. So, I don't know. So now, let's go on over to our comments that we've gotten in since yesterday. And they've all come in under my video from yesterday. And this was about the hidden methane threat from New Zealand. The methane stores that have been found off the east coast of the Northern Island. And the chance of earthquakes over there, the fault zone over there. And the first comment comes in from Robin. His YouTube name is Seymour Rocks 97. And he says, "Thank you, Margo, for covering this. A large area of methane hydrates, precisely where they have identified the possibility of a megathrust earthquake, is, to put it extremely mildly, a huge worry." I would say so, Robin. It's a huge worry, all right. And, I don't know how you guys are going to prepare for something like that, for the kind of tsunami that would come in and the methane release. And from the article that I read, that the earthquake people were talking about the fault line, they didn't mention the methane hydrates. That was from your research and my research, some more articles. So, I wonder if they know about that. Well, they'll find out. So thanks for that comment, Robin, and thank you for all your great research and your library, your blog, your library. I'm finding it invaluable. And Valhalla 56 says, "When they find these large fields of hydrates outgassing, it makes me wonder how many do they not know about." I know, Valhalla. I mean, they can't send out teams to just go scour all of the ocean floors. I found an article about hydrates that were found off the east coast of the United States, out in the Atlantic Ocean. And I'm thinking that they're all over the place, just depending on the depth and the geography of the seafloor. They're all over the place. So, and as the planet gets warmer and we have more earthquakes and shifting of the plates, these hydrates are going to be exposed to warmer conditions and going to be melting and coming up. So I agree. I think there's a lot more. This comment comes in from Francis Formalhout Moon, and he says, "Last summer in Nelson, in the South Island of New Zealand, I had an old 94 model Toyota people mover. I also had a laser thermometer gun. At the heat of the summer, I owned my laser gun. And at the heat of the summer, I'm having a little bit of problem reading this, interpreting exactly what you're trying to say, but I think you're trying to say that you put your laser gun at the fabric on the seat of the old Toyota, And guess what the temperature reading was? Wait for it, 90 degrees centigrade. And where solar radiation converged with the fabric, the boiling point of water has about 100 degrees centigrade. Given that the higher truth channel guru asserts that solar radiation is becoming more and more dangerous and factoring and all the other stuff, I make the declaration sitting in my four-wheel drive in Auckland at the moment that within about 18 months or so, cars and vehicles are simply bursting to flame while sitting, as I do all over the place, kind of like California on steroids. Thank you. I agree, Francis, Formal Hot Moon, and I'm a subscriber to the Higher Truth channel, and I've watched a lot of his videos about the solar radiation, and he apparently is a health expert. He's in the health field, and he sees a lot of burns, radiation burns that people get from being out in the sun, a lot of skin cancers and all kinds of things from people being out in the sun and it burning them right through their cotton shirt or their clothing. And I agree with you. You know, the things are changing. The planet has changed. The atmosphere's changed. The magnetosphere has gotten thinner. The ozone layer has gotten way thinner. And if you look on cams at the ozone layer in over Australia, it's really thin, and that's a little bit better in New Zealand, but depending on the time of year, you get that hole down there. And so, but just to look at, for people who don't know what 90 degrees centigrade is, over here I have a cheat sheet, and so this is for people who live in the Western world like I do, I mean the Western part of the hemisphere. Actually, it's not on this chart. 90, let's say, hang on. Okay, I pulled up a different website converter. So 90 degrees centigrade or Celsius would be 194 degrees Fahrenheit. So that's wild. That's wild, Francis. And but I believe it, because when you're in the car and you know that radiation is building up in the car and in the sun, it just gets higher and higher and higher. And I know when I'm driving around, even in the winter time, you know, in the car with the sun beating in, I feel like I'm just going to burn up and come out of my skin. So, and it's not from the heat, it's from the radiation and the lack of the UV layer and the cosmic radiation that's coming in is more, and solar radiation, and it's unbelievable. But I believe you. So thank you for being here, and thank you for your comment, and thank you for checking in with us from down under. So I'm finding I've got quite a few listeners from Australia and New Zealand, and so I'm really glad to have you here, and all of you here. And I will make it a point to be covering the Southern Hemisphere more and more as time goes on as well. Then Darren Copel says, it's a worry that the Ring of Fire is not far. I live in Napier, and there was an earthquake in the 1930s that killed a few people and pushed land up, making the Napier airport. There was not a tsunami as far as I know. If we get a megathrust, then a wall of water would cover a third of the northern island, apparently. Yeah, Darren, I know, it's crazy. And just so people see where Napier is, I've got Google Earth pulled up here. And here's the northern island, and this is Napier right here. Right there on the coast. Gisborne is up here. And then those methane hydrates are off the east side over here. They're right over here. So Napier is right there. Auckland is up here, along with Temps. And so I didn't know where any of these were till I started getting ready for my presentation today. Christchurch is right down here. So there's that. And then Troy Turton says, oh, well, first of all, I meant to say thank you, Darren, for your comment and for following and for watching. I appreciate you being here and checking in from down there. So now Troy Turton says, good map for the methane deposits that have been discovered around the world, and another article about it. And these are good links. And this is from usgs.gov. This is an article about methane gas hydrates. And then here's the map. And I encourage everyone to come over here and download it. It's a PDF file, I think. Anyway, you can download it and enlarge it. I've seen this map before. I didn't know where it came from. So thank you, Troy, for doing that research and sending this to us. The yellow dots are recovered hydrate, and so you can see that that means that they've been drilling. The red is inferred hydrate, and the black is drilling expeditions. So so the red means where they could be drilling in the future, and the black means that they are drilling or have been drilling, and the yellow means that they drilled and recovered. So it's all around the planet. It's all around. And see up here off the coast of Norway and Iceland, and then up here in the Arctic. Look, right up here, right by the North Pole even, they've been drilling. And over here in the Pacific Ocean between Russia and Alaska, you know, that's just... And look, here's New Zealand. So they've recovered down there. So they're drilling right in, they've been drilling and recovered right in that area off the northern coast, east coast of the northern island. And we all know about the mess over here at Gulf of Mexico, and the BP oil disaster, and supposedly that's still leaking. So that's an excellent map, Troy. Thank you for that. And then he says, talk about freezing your ass off. The freezing point of methane is minus 295 degrees Fahrenheit. Say what? LOL. So, yeah, so it's gonna be coming up as things heat up more and more. And then my friend David Alcock from England checks in, and he says, death by stink bomb. Hi, Margo and fellow truth seekers. Thank you for the information on NZ. It's not an area I've explored before, and I found it very interesting. It has just come to my attention that the Baltic Sea has become a dead zone. The combination of nitrate runoff from northern Europe coupled with higher than usual ocean temps has resulted in deoxygenation oxi oxygenation of this large body of water. It's going to get very stinky this summer when the toxic hydrogen sulfide starts bubbling up through the surface layer of rotting dead fish. Anyway, on another subject, I have throughout my life embraced new technologies. However, the recent pace of change and the madness that is about to be unleashed regarding nano AI, magic dust, and the rollout of 5G, get your tin hats on, folks, along with the total lack of action to combat climate change, has me questioning my own reality. At least cams will load up faster for you, Margo, on 5G, assuming the data is available. With truth comes power. God bless you. Thank you, David, for your comment and for being here and for contributing. And I'd like for you to contribute as much as you feel comfortable with. You've got a lot of good insights and information. And I didn't know about that Baltic Sea, so we'll be watching that as the summer approaches. And as for 5G and AI and the smart dust, you know, people are not going to need to be chipped. We're already chipped because of all the nano crap we've been breathing in, and it gets in there, and we've got all these heavy metals in our bodies, and we're just walking antennas. And so 5G will be playing into that. Frankly, I'm not going to survive 5G. I already know it. And then Dave also says, I forgot about the mega snowfall in Europe. 8 foot in many places, not drift. With more and more forecast, they're in big trouble if it keeps up for several weeks, not to mention the flooding if there's a quick thaw. This is a negative feedback response as the Earth tries to readdress the balance by increasing its albedo. And another good observation, David, so thank you for that. Yeah, Europe is in trouble. And so, you know, all of these systems getting out of balance, this is what the climate scientists have been talking about, and the jet stream going wonky, and you know, being cold where it's supposed to be hot, and vice versa, and raining where it's, you know, not supposed to be. You know, it's just, and then once it starts, it won't stop, and once it starts snowing, it won't stop, and it's these mega storms because the atmosphere is holding more water, and so there's more moisture to come down, and it's to be expected. Thank you, David. And then Tom Bell chimes in and says, glad to hear your cough is much better. Love your work. God bless you, Margo. Well, thank you, Tom Bell. God bless you too, and thank you for being here. And you know, my cough comes and goes depending on how my allergies are that certain day. So far, so good at this point in time. So now we'll have that as our backdrop. Let's get right over to our earthquake report. I have USGS pulled up here. This is 1 day all magnitudes worldwide, and for 24 hours we've got 245 earthquakes showing on this map. And then if we hop over to 2.5 magnitude and higher, it's showing 28 earthquakes. So let's start with this map and get these ones before they start falling off. And it's 4:17 p.m. Pacific time as I'm starting the earthquake report. And so the first one that's going to fall off my map here is a 2.9 from Parkfield, California. that occurred yesterday at 4:47 p.m. Pacific time, 4 kilometers deep. And that is on that San Andreas fault line. It is on that red line right there. So that was a little bit higher than we normally see, or than we've been seeing. So now the next one coming up, and we'll just continue with this. So Tonga, so let's start down here in the South Pacific. So we discussed New Zealand in detail, so now you know a lot more about this area, these two islands that make up the country of New Zealand, and about this fault line that runs very near the east side of the northern island, and then it crosses over the southern island and runs along the western coastline. So anything that shakes these plates is going to affect New Zealand in a big way. So coming in, let's see what we've had here. We've had a 4.7 at South Tonga, 10 kilometers deep, a 5.2 near Ohonua, Tonga, 10 kilometers deep, and a 4.8 near Fiji, 543 kilometers deep. So that was a deep one right up here. And so with the deeper earthquakes, that's what causes the shaking around the plate. So let's continue around our ring of fire here. Then this one, there was a 4.8 at New Caledonia today at 1:24 p.m. Pacific time, 10 kilometers deep. So it was on that red line. So let's come on around to Indonesia and Philippines. Right up here, there was a 4.8 near Tobelo, Indonesia, and a 4.5 at the same place. This one was 57 kilometers deep. The first one was 10 kilometers deep. Now let's come on down. Here's Sumatra, this island of Sumatra. This 5.4 off the west coast of Sumatra, 43 kilometers deep. It happened at 11:05 this morning. And then a 4.3 west of Sinabang, Indonesia, 10 kilometers deep. And I think there's volcanoes over there too. So there's that. And then up here in Greece, there was a 4.4 near Lathakea, Greece. Today at almost 11 o'clock this morning, 17 kilometers deep. That's on a red line. So that area has been active. So that covers all of that area. Let's go up to Russia. We had another one off the coast of Kamchatka. I think it was just one. It was a 4.7 and it was 10 kilometers deep. And remember, this is an active area because it's where the northern plate and the Pacific plate come together. And so all of this area where the Pacific plate and the northern plate come together, you're going to have activity going on. So let's go down to South America now. And there was a 4.4 near Copiapó, Chile, 93 kilometers deep. That was today at 4:22 this morning. And a 4.6 near Pelora, Ecuador, 140 kilometers deep. And that was at 3:02 this afternoon. Now let's go. Now we're ready for, I think that's all of the international earthquakes. Okay, so let's hop down to Hawaii. The highest magnitude, we had a 3.0 at Volcano, Hawaii, today at 3:42, 2.8 Pahala, and 2.5 at Volcano. And let's see, let's get all magnitudes and look at Hawaii. So they've had 16 total. So I just showed you the highest ones, and they were the ones most recently, and then the ones before that were 2s and 1s. So we can zoom in and see. So we saw a larger number of earthquakes here today. Now let's go over to Dominican Republic. And we're showing 5 earthquakes on the map today. 2.7, 2.1, 1.4, 2.4, and 2.3. So not much activity in the Dominican Republic area today. Now let's go up to Alaska. They've had some activity up here today. Let's start with our 2.5 magnitude. Okay, we've got 8 that registered 2.5 magnitude and higher, starting with a 4.7 near Big Lake, which is in that Anchorage area where the 7.0 happened a few weeks ago, and it was 50 kilometers deep, and that happened last night at 6:33 p.m. Pacific time. Then 2.5, 2.8, 2.6, 2.7, 3.0 at Chignik Lake, 3.8 back up at Big Lake, and 2.7 at Kuktovik. So let's go to all magnitudes now and just get an overview. So for all magnitudes for Alaska in the last 24 hours are 97. And so you can see them coming down through the middle of the country. Just coming down and clustered down here. This seems to be the hot spot down by Anchorage. So now let's come down to the United States and see what's going on. Right off the bat, there was a 2.4 at Hunter, Tennessee yesterday. At 10:39 p.m. Pacific time. 10 kilometers deep there. Now let's go up to the northwest and Yellowstone. Let's start up here in the Seattle area. Looks like we've got 2 on top of each other. Here was a 1.9 and a 1.3, both near Lowfall, Washington. Here's a little one right here, a 0.2, west of Seattle, 24 kilometers deep. Then here was a 1.2 near Amboy. Here was a 1.9 near Teton. And then two little ones, a 0.1 near Intiot and a magnitude 1.0 explosion near Intiot. And it was at minus 1.2 kilometers deep. So that was up in a mountain, or on a mountain, blasting. And it could have caused this earthquake. Let's see which one happened first. Okay, the quarry blast. Oh, that's Butte, Montana. I've got Yellowstone on the map. Let's see which happened first here. The blast happened first. There's the 0.1. It happened at 12:13 p.m. today. And wait, the explosion happened last night. At 8:47 p.m. That's kind of late for them to be exploding stuff. That is late. They shouldn't be working at that time. But I'm just reporting. So we saw that one. Now let's come across to the Yellowstone area. Starting out 0.2 near Ronan, Montana. Here's a 0.6 at Lincoln. 1.3 near Lincoln. 1.2 near Helena Valley Northwest. Here's a quarry blast, a 1.4 magnitude near Butte, Montana. Minus 2 kilometers deep. So that's up in the mountains. It's pretty high up. Here's a 0.6 at Butte, Montana at minus 0.3 kilometers. So it's up in the mountain again. So again, you know, the quarry blast, which happened first. Let's look and see. No, they just had the quarry blast. So that's not a good idea. Here's a 1.2 near Manhattan, Montana. Here's a 0.8 near Big Sky, Montana. And then a 1.6 near Soda Springs, Idaho. So total of nine earthquakes right here. Now let's come on down into Utah. This is part of the danger zone. There's Soda Springs, we saw that. Here's a 0.6 near Providence, Utah. And then we had down here a 0 at Milford, Utah. A 1.8 near Beaver, Utah. 1.0 near Enterprise, Utah. And here's one right on the line. 1.5 near St. George, Utah. We saw a whole bunch down here. It's actually across the border in Arizona. Remember, we saw a bunch down here the last few days. Okay, the rest of the Southwest looks clear from this map. Then let's come across to California and Nevada. Let's start with the geysers. 15 on this map. Let's see what the biggest one was. There's a 2.1. I won't call them off if they're under 2. Okay, that was the largest one. The rest were under 2s and 1s. So let's come across to, here's a little one. Oh, more than one. Looks like we've got two in the west of Truckee. There's a 0.8 and a 0.2 west of Truckee. Here's Lake Tahoe. You all know that area now. We've got three, looks like three little quakes here in the Mount Rose area. Here's a 0.1, a 0.4, and a 0.7. So little ones up there. Now let's come on up. Reno Sparks area. Okay, here's one over here at Portola, California, 11.7 kilometers deep. It was a 0.6 magnitude. And then one near Cold Springs, 11 kilometers deep. It was a 0.3 magnitude. Then we've got another explosion. This is a 2.0 explosion northwest of Lovelock. I've told you about Lovelock and the cave there where the giants were. Here's Lovelock down here. The Lovelock cave is down here. I mean, you have to go to Lovelock and then get on the road and then come back around through, and it's part of this Humboldt Range. It's down here somewhere. It's not easy to get to, and then you have to go up the trail, and it's really steep. And anyway, so this 2.0 magnitude explosion was 6.4 kilometers deep, and it happened at 3:41 today p.m. So they're blasting away. There's some weird stuff up there. There's a sulfur mine up there. That might be where that sulfur mine is. If you want to look at Google Earth, we can go look and see. We'll do a Dutch sense here. So we were looking at New Zealand. Let's put in the coordinates for this earthquake or this explosion. I almost get dizzy going in. Okay, so there's our area. Now let's look at where Lovelock is. Okay, so this is north of Lovelock from what we saw. Here's, okay, this is that big, I think this is a sulfur pit or a sulfur mine, but this is some kind of huge mine here, and so I don't know why my things aren't showing up here. Trinity Peak. So it was up here in the mountains, so they were blasting, probably doing some mining of some kind. That's a very active mining area. So there's that. So we saw that explosion now. Now down here, here's another one near Virginia City, a 0.7. We saw some yesterday as well. Now, here's one near Smith Valley. Here's Walker Lake. Here's one in 1.4 at Hawthorne. And then we're just seeing them peppered around through the Hawthorne area and the Nevada test site and so on and so forth. It looks pretty active today, doesn't it? We saw that 1.4, but it definitely is looking pretty active. Here's a whole stack. Here's 30 right there in a row at Alamo. So stuff is happening. Look, here's one to the west of Las Vegas, a 1.0. We saw one there yesterday too. This happened today at 1:03 p.m. 19 kilometers deep. And then we're seeing some right across the California border. Small ones, 0.6, 0.2. So let's leave those and let's come over to California now. Okay, so we saw the geysers. Here's one west of San Jose. It was a quarry blast that caused a 1.4 magnitude earthquake. It was minus 0.3 kilometers deep. So it was up on a hillside or in a mountain. Here's a 1.1 on this red line. San Andreas fault line near Amesti, California. Now, let's go. Here's these three over here. I don't see where that one's showing up. Oh, it's over there. Tom's Place and Mammoth Lakes, 0.9, 0.7, and 0.2. So there's Mammoth Lakes. Here is a 0.3 at Coso Junction. And these are areas that get hit like every day. It's at least small ones every day. Okay, let's look down here. South of Bakersfield, there was a 2.8 near Grapevine at 9:43 this morning. That's pretty good size. Did we see this one? A 1.7, yeah, at similar. And then two more here. Here's another quarry blast, a 1.0 near Mojave. It was minus 1 kilometers deep, so it was up in the mountain or on the mountainside. Here's another quarry blast of 1.2 magnitude near Mojave again, and it was a minus 0.8 kilometers deep. Another on the mountainside. So they're blasting away. Blasting. That can't be good. Here's a 2.0 near Orcutt, California, 2.2 kilometers deep at 5:04 this morning near Santa Barbara. Now we're moving on down into the Los Angeles area. So look at, okay, we've got a stack here, a 3.1 at Yorba Linda happened at 1:19 today. And then a 1.4 happened at 1:21. So 2 minutes later, right in the same spot. 3.1, that's good size for being in the city. Here's some little ones. Here's a quarry blast. Why are they blasting in LA? Here's a 1.1 near Home Gardens, California. It's a quarry blast, minus 0.5 kilometers deep. And another one, quarry blast, minus 0.5 kilometers deep, that caused another 1.5 magnitude earthquake. So this one was at 2:05 today, and this one was at 12:54, so about an hour apart. Blasting away. Makes you wonder. It just makes you wonder. Here's one in Tijuana, or near 1.4. Today at 4:10. Here's Salton Lake, 2.2 at 8:55 this morning. Here's a big dot. Here's a 2.2. This is in the Kauai area where we see all those stacks. That one happened at 2:05 today. So, there you have it. See what else is going on down here. I think that's it. How many are on the map? Right here in Southern California. 40. 40 on the map. So we saw, here's one quarry blast, another quarry blast. There's two. I'm just counting quarry blasts down here right now. So 2 quarry blasts. So let's zoom out and see if anything else came in during our report period here. We had some more come in up at Big Lake. We had a 2.5 at the geysers, 2.4 at the geysers. I don't see anything major. Let's zoom out of this map. I think that's it. I think we're good for today. We got, oh, did we get this one? Yeah, Volcano Hawaii, the 3.0. Sometimes they post these quite a bit after the time it happened. So, like, I'll do an update, and then after I do an update, they'll put it on, and it's after the time, before the time I put the update up, or anyway, they report it late. This was at Volcano Hawaii. Let's make sure we saw that. Yeah, 3.0. There it is. And we saw the one in Ecuador and New Caledonia. So I'll wrap this up for today. I hope everyone has a wonderful weekend. I will keep reporting, and as long as I'm able to. So until next time, everyone go in peace and God bless. I do think that time is short, and I recommend everyone get their spiritual houses in order. So I will talk to you very soon. God bless you. Go in peace, and good night.